Okay, so in this video, we're going to start the notes for Unit 3.4, so make sure you have your notes for Unit 3.4 out. Before we do that, we're going to take a look at this Do Now question using our notes from Unit 3.3. Okay, so this question says, which of the following chemical equations are not balanced? Okay, and so in the last lesson we learned about balanced chemical equations. And so using your notes and by looking through all three of these chemical equations, try to see which of these are not balanced, or if you think all of them are balanced, then you can select D as your answer. Okay, so pause it here and try to answer this question on your own. Okay, so the correct answer to this question is actually A. And you can see that just by counting how many of each type of atom we have on each side of the equation. Okay, so if you look at A and you break A down, we have one sulfur atom on the left, we have two oxygen here, and two oxygen here. Okay, so that's four oxygen atoms on the left. And then on the right side of the equation, we have one sulfur, and we have three oxygen. Okay, so we have the correct number of sulfur atoms, but we don't have the correct number of oxygen atoms because 4 is not equal to 3. Okay, and so that equation is not balanced correctly. B and C are both balanced correctly, and hopefully you recognize that. Okay, so pause there if you need to look at that some more. All right, so today we're going to start the notes for Unit 3.4, talking about exothermic and endothermic reactions and nuclear reactions. In this video, we're going to talk briefly about exothermic and endothermic reactions, and then in the next video, we'll talk more about nuclear reactions. Okay, so exothermic and endothermic reactions are basically two types of chemical reactions. And just to give some background, when you mix chemicals together, um, what can happen is you can have a temperature change. Okay, and that could be a clue that a chemical reaction has taken place. Now, that's not the only possible clue that a chemical reaction has taken place. And we've talked about chemical changes and physical changes before. And other clues that chemical changes have occurred would be like if a gas is produced, if there's a smell, if there's a color change. But a temperature change is one example of a clue that a chemical reaction has taken place. And in fact, most chemical reactions do involve some type of energy. And sometimes that energy is electrical energy, sometimes it's light energy, like sometimes you mix things together and they produce light. But almost all chemical reactions involve heat energy. Okay, either they produce heat or they absorb heat. Okay, and so just going a little bit further with the background information, when you have a chemical reaction, when there is a temperature change, energy can basically be exchanged in two different ways. And what happens in a chemical reaction is that you're basically taking the bonds between atoms and the molecules and breaking them. And so what could happen, one possibility, is that energy is absorbed in order to break those bonds. Um, the other possibility is that when the products form, new bonds are made and energy is released when those new bonds are made. And this equation right here basically just shows you that you could have energy on either side of the equation. Either energy could be absorbed on the left side or released as a product on the right side. And the last bullet point says if the amount of energy needed to break the bonds is different from the amount of energy needed to form the bonds, then the temperature is going to change. Okay, so in other words, you're going to get a temperature change if either you have more energy on the right side or more energy on the left side. And so when we talk about exothermic or endothermic reactions, we're basically talking about those two possibilities. Okay, so let's talk more about classifying reactions as exothermic or endothermic. Okay, so reactions can be classified based off of the difference in the energy exchange. If you have a reaction that absorbs more energy than it releases, the reaction is what's called endothermic. Okay, and so endo basically means like into, and thermic kind of comes from like thermal, meaning heat. And so an endothermic reaction is a reaction that basically absorbs energy. It absorbs heat. If the reaction releases more energy than it absorbs, then we say the reaction is exothermic. Okay, so exo here means like outer or outside, and thermic again means heat. And so an exothermic reaction would be a reaction that releases more heat than it absorbs, and so overall releases energy, releases heat. And so when you're trying to figure out is a reaction endothermic or exothermic, really the key difference between the two is you're looking at is heat being absorbed or is heat being released in the reaction. If it's being absorbed, it's an endothermic reaction. If it's being released, then it is an exothermic reaction. Okay, so here are some examples of endothermic reactions. An endothermic reaction is a reaction in which more energy is absorbed to break the bonds than is released in forming the bonds. Okay, and so what happens in that situation is that the molecules and atoms making up the object are actually going to absorb energy from their surroundings. And so what that means is if they absorb energy from the surroundings, then if they're inside a container, then the container is actually going to feel cold, or it's actually going to get colder than it was before because it's like they're sucking all of the heat out of their surroundings. Okay, and so here you can see in this little animation here, you can see like the heat being absorbed, going into the reaction, and that would be what an endothermic reaction would look like. Okay, so you have energy on the reactant side as opposed to the product side. Okay, so here are some real life examples of endothermic and exothermic reactions. Okay, instant cold packs that you can buy at the store like CVS or Walgreens. Those are examples of endothermic reactions. They absorb heat from their surroundings, and so that's why the cold packs get really cold. When you bake bread, the um, the bread absorbs the heat from the oven, and by absorbing that heat, it cooks. And so that would be an example of an endothermic reaction. Or when you go to fry eggs and you put the eggs in the pan, the eggs are absorbing heat from the hot pan, and because they're absorbing heat, that is an endothermic reaction. Okay, so those are just pictures showing that. Okay, and so by contrast, you have exothermic reactions, which are kind of like the opposite. And an exothermic reaction is a reaction in which more energy is released to form the bonds and is absorbed in breaking the bonds. Okay, and so this is where the reactions are going to release heat, release energy to the surroundings. And so if the chemicals are in like a container, then the container is going to feel warm. It's going to release heat. Okay, so here you can see in the animation heat is coming out of the flask. Okay, so here you can see exothermic reactions can be written as reactants yield products plus energy. In other words, you have heat energy on the right side because it is produced in the chemical reaction. Okay, so here are some examples of exothermic reactions. We saw this a few classes back. When you put sodium metal into water, sodium is an alkali metal, and so it reacts violently with water. And what actually happens is it produces a lot of heat, and it produces hydrogen gas, and that gas can catch on fire and explode. And we actually saw some dramatic examples of that with other alkali metals as well. And so that would be an example of an exothermic reaction because heat is being released in that reaction. Another example of an exothermic reaction would be the burning of wood. So if you take a piece of wood and you set it on fire, right, it is combusting and that chemical reaction is releasing heat. Obviously, fire is hot, and so that heat is being produced as a result of that chemical reaction, the burning of wood. Another example of an exothermic reaction would be cellular respiration. And of course, fireworks are a classic example of exothermic reactions because they very visibly produce heat, and not just heat, but also light, and they look awesome. Okay, so these are all examples of exothermic reactions. So remember, endothermic reactions absorb heat, exothermic reactions release heat. Okay, so pause there if you need to look at that some more. Okay, so let's just do some basic examples. Classify the following situation as either endothermic or exothermic. An ice cube melts after being left out on the table. Okay, so this is actually an example of an endothermic reaction. And the reason it's an endothermic reaction is when you have a solid ice cube melting, when you go from a solid to a liquid, remember the atoms in a solid have the lowest possible energy. And so in order to go from a solid to a liquid, those atoms have to gain energy. And so energy has to be absorbed. Okay, so the atoms making up the solid have to absorb energy, then they can move faster. And because energy is being absorbed, it is an endothermic reaction. Okay, so pause there if you need to look at that some more. All right, let's try another example. Okay, classify the following situation as either endothermic or exothermic. Dynamite explodes in the destruction of a building. Okay, so this is going to be an example of an exothermic reaction because heat is being released in the dynamite. Okay, and I don't need a chemical equation to tell me that because when the dynamite explodes, it's obviously going to release a lot of energy. Okay, so that's going to be an exothermic reaction. All right, and then one more example, I believe. Okay, take a look at, actually, I guess that's the last example. I thought we had one more example. Okay, so actually, I'm gonna put in a video here having to do with the difference between endothermic and exothermic reactions. So I want you to watch the video and answer the questions. Okay, so as always, please let me know if you have any questions, and I'll see you guys in the next video.